Now, here's the square root function, which its name says it. The square root function pairs every real number with its principal square root. For the function to be a real number, we have to restrict our domain. I hope you remember from our previous chapters that when you take the square root of a negative number, we have to use that I symbol for imaginary numbers. We don't want imaginary numbers, we only want real numbers. So we're going to change our domain from negative infinity to positive infinity to only the positive values, because I can only take the square root of values that are greater or equal to 0 in order to get a real number. So my domain is from 0 to positive infinity, including the 0, because I can take the square root of 0. And due to this, my graph is only defined for my y values from 0 to positive infinity as well. So my domain and range are both from 0, including 0, to positive infinity. If I walk on my graph from left to right, I'm always going up, which means my graph is increasing over its entire domain, which was from 0 to positive infinity. On the same hand, we have the cube root, but because this is a cube index root, meaning that the index is 3, I can't take a cube root of negative numbers and get an answer in the real numbers, which means the domain for this function is not restricted. My domain is from negative infinity to positive infinity, and my graph keeps on going downwards and upwards very slowly, and making my range also be negative infinity to positive infinity. If I walk on my graph from left to right, it looks like I'm also always going up, which makes my graph to be increasing over the entire domain, which is from negative infinity to positive infinity. This cube root function pairs every real number with this cube root. And I guess that's it we can say about this cube root function. Now we're going to talk about the absolute value function as well. I hope you remember that the absolute value, which is symbol with 2 straight lines, think of a flat parenthesis, it just cares about the value of the number, about whatever measure or quantity it represents. It doesn't matter to us if it's positive or a negative number. For example, the absolute value of positive 3 and the absolute value of negative 3 are both 3. Think of measuring. You can never measure negative numbers when you're actually using a ruler to measure something. So absolute value represents the amount or the quantity that the value represents, whether it's positive or negative. The absolute value function pairs every real number with its absolute value. And if you notice at the values, we have negative 2. The absolute value of negative 2 is 2. The absolute value of negative 1 is 1. And the absolute value of 1, 2, and 0 are also 1, 2, and 0. All of my y values are going to be positive, which means my range is from 0 to positive infinity. My graph is only defined above the x-axis, but it does include 0. My domain is all real numbers. My graph keeps on being defined towards negative infinity and positive infinity on the x-axis. And if I walk on my graph from left to right, it's decreasing from negative infinity to positive infinity and increasing from from negative infinity to 0. It's decreasing from negative infinity to 0 and increasing from 0 to positive infinity. Since I can graph my function over its entire domain without lifting the pencil from the paper, my graph is continuous over the entire domain. Here's another way of explaining the absolute value function, if your x is negative, it's just negative x. Whenever you have, let's suppose we have negative 3, that's my x. As per my piecewise function right here, which we're gonna talk about in a second, my x is smaller than 0, it's negative, and I have to use this formula, negative x. If I take negative 3 and put it into my negative x, it's going to be positive 3. And if my 3 was positive, it will have been just 3. This is just another way of explaining what the absolute value is, that it only cares about the value of the number. And like I was mentioning to you, the absolute value can be defined as a piecewise function because different rules apply to different intervals of the domain.